Hello, my name's Paul Bevan from Siemens Digital Industry Software, and in this demonstration I'm going to show you how algorithmic modeling inside of NX can help me generate the display values for the flow control dial in this shower unit. So I'm going to start by isolating the shower cover. And you can see I have a curve that defines the placement position for the display. Now I could use the text feature in NX to create my display. Simply pick on the face, pick on the curve where I want the text to be positioned. I can move it around, I can change what's in the text itself. And that's fine for this part. But I really want something a bit more dynamic and something that either myself or colleagues can reuse for other components. And to do this, I'm going to look at using algorithmic modeling. Now if we take a look at the part navigator, I already have a partially defined algorithmic feature. And we're going to use this to complete the generation of the display. So I'm going to edit the feature definition, and by doing that it takes me into the logic editor environment with my rules window, graphics window and Node Explorer. I'll just zoom into the display area in the graphics window, and now let's take a look at the rule. You can see we have a text on face node. This is a new node in the latest release of NX and one that we'll use to develop the dynamic display. If I preview what we currently have, then you'll notice there's a single block of text that's positioned halfway along the guide curve. Now I really want to create a dynamic display, so let's see how we can do that. First thing I'm going to do is to search for an applicable node to create my range. Once I find it and position it, then I can start to create my inputs. So we have a start and an end input for the range. I type in some values. And finally I'm going to divide my range. So I create an input for the divisions port, and you'll notice that NX has smartly predicted nodes that I may well want to use. And this is based on previous workflows and really helps speed up rule creation. So I'll select the subtract option. I'm going to delete the pre-configured inputs because I want to use my own, namely the start and end values I just created. And when we take a look at the output from the range, you'll see that I have a list with 5 objects. I'm just going to refine the range output by removing all the trailing zeros. Just going to add a truncate node to the output of the range, and now when we take a look at the list, you'll see that those zeros have been removed. Now much of the effort when creating rules involves working with and managing lists. To further develop my rule, I'm going to need to merge 3 lists together. So I find the applicable node, bring it into my rules window, and then start to define the inputs. The first input is going to be the lowest value for my display. I can rename the node to reflect that and type in a value. You can copy and paste nodes to speed up rule creation. Here I'm going to define the highest value for my display, and again input the text for that. All I need to do now is to connect the other 2 lists to the node, and when we take a look at the output from the merged node, you can see we have off, we have the range in between, and then the highest value max. Now that I have the output from the merge list, I'm going to use it to help define the spacing for the figures in the display. To start the process, I'm going to generate a list length. And this list length gives me a figure that I can use to help define the spacing around the guide curve. You can see from the output that I have one object with a value of 7, which is exactly the same as the number of figures in my display. So I'm going to use the output from that node to create some points on the guide curve. I find the appropriate node, bring it into the rule window, and start to connect the ports. So I'll start by connecting the curve port, and then the output from my list length will be connected to the divisions port. Now that the node has been fully satisfied, we can preview the points in the graphics window, as you can see. Now that we have the equally spaced points around the guide curve, we can use them to divide it. So I'll search for the divide curve at point node. Once I find it, I can bring it into the rule window and start to connect the ports. Again, connect the curve port and then the points port using the output from the points on curve node. When you look at the connection for the guide curve on the text on face node, it's connected to the original curve, which isn't going to give me what I need. I need to connect it to my divided curve. So I simply delete the original connection and reconnect the guide curve to the divided curves output, and you notice immediately that the preview of the display updates. It now shows 7 text blocks around the guide curve. I have one more modification of the rule to see the correct figures in the display, and that's to delete the original text and reconnect the merge list to the text port in the text on face node, and you can see now that we have the correct figures. And as I said right at the beginning, the whole reason for creating this rule was to get a dynamic display. And as I change the value of the range, you'll see I have more figures in the display. If I revert back to the original value, then again it updates to reflect that. To finish the rule creation, all I need to do now is to create the output. And there we have it. Our rule is now complete. Now, not only do we have a reusable rule, but during the rule creation process, NX has automatically been generating the dialog for the rule in the background. And it's a dynamic dialog, so if I change the text size, for example, and OK the command, the preview updates. Another important aspect of the dialog is that it's fully configurable. You can hide certain groups within the dialog. You can change the title of groups within the dialog as well. So you get the dialog exactly the way that you want it to be presented to yourself and to other users within the organization. And you can preview the configured dialog to make sure it's correct. And if you're happy with it, you can then save the rule, either to the reuse library for others to use, or, as in this case, I'm just saving it directly within the part file. So I've got my dynamic display. What I'm going to do now is to extrude the figures as solids and add them to the shower cover. Now this could have been part of the rule, and I may go back in later on and modify the rule to include the extrude. So let's go ahead and edit the rule and update the model. Select the feature, make some modifications to the dynamic range. We're going to change the max and min values for the flow control, and you see the immediate dynamic update. Let's go back to the shower casing assembly and make a design change in the context of the assembly. We access the algorithmic feature again. We make a change to the dynamic range and also to the max min values and update the model. And you can see it updates immediately. So just to recap what you've seen, you saw me create a rule-driven display for a shower flow control which had dynamic content using algorithmic modeling. Within the logic editor environment, you saw how we were able to create the dynamic range, merge lists, and define the equal spacing for the text around the display guide curve. Finally, we looked at how you could reconfigure the automatically generated dialog for the algorithmic feature so that you're only presented with the information that you need to see. I'd like to thank you for your time and attention.